then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Tis the season to be serving.
When I was solving equations, I was feeling amazing.
Greetings, pre-calculus students. Welcome to lesson number 8. Lesson number 8 is about vertical asymptotes. And I know you've seen vertical asymptotes in pre-cal and probably algebra 2 and maybe even algebra 1. Still don't think you really have a full understanding of what they're all about. But really what we're more focused here is the limit definition of a vertical asymptote. So we want to look at the limit definition of a vertical asymptote. So we're not going to review anything today. Today's lesson is going to be quite short, and I hope it will be very easy to understand. So let's go and get right into the vertical asymptotes. All right, vertical asymptotes. So those of you that have been with me before should be proud of the improvement in my handwriting. So I've really put some time in improving my penmanship this particular summer, and so I think I've done well. So you guys should all be proud of my achievements. All right, but vertical asymptotes, correct? So let's put a Cartesian plane here. Actually, I don't even need a Cartesian plane. Let's say this vertical line here is my vertical asymptote. So this is, I'm going to abbreviate and call it VA. So this is my VA, and it's some value x equals k. So a vertical asymptote is a vertical line. So its equation is going to be x equals some number. And it's a vertical line that a graph of a function comes close to, but never touches for the most part. So anyway, that's how you're given that definition in pre-cal and algebra 2. That is a part that the graph never touches, but comes very close to. Unfortunately, there are some very unique functions. Well, I know of one at least, where the function actually touches the vertical asymptote. But for now, you're a bit too young to think about that function, so don't even think about that function. So for you as of now, a vertical asymptote is a vertical line that a graph gets very close to, but never touches. So let's look at what happens. So I'm going to put the graph of f of x in red here. So this is the graph of f of x. And so what happens, no matter what, Okay, I'm not sure if this pen is ready for prime time, but let's go. Okay, so no matter what happens, the graph of f of x, it could be doing whatever it's doing. Once it gets to that vertical asymptote, it's going to do one of two things. It's going to shoot straight down, or it's going to shoot straight up. And so that's how you can identify, if you're looking at a graph, where your vertical asymptote is, because you're going to see the function shoot straight down or shoot straight up. And so whenever you see that action going on, that's an indication of a vertical asymptote. So since that's the indication, let's think of this from a limit point of view. So we're saying x equals k is my vertical asymptote. And this in red, this is the graph of f of x. So that's the graph of f of x in red. So then what is the limit of f of x as x goes to, say, k minus? What's the limit of f of x as x goes to k minus? Again, this is k right here. This blue line is a vertical asymptote at the value x equals k. What's the limit as f of x? What's the limit of f of x as x goes to k minus? I'm hoping you're saying negative infinity. So then a follow-up question is, what's the limit And I got a little sloppy on my handwriting there, so I'm going to slow down and concentrate a little on this guy. So what's the limit of f of x as x goes to k plus? Hopefully you'll say infinity. Now, I submitted to you today that when you have a vertical asymptote, every time the function goes towards that vertical asymptote, it's going to shoot straight up towards infinity or straight down towards negative infinity. So therefore, the limit definition of a vertical asymptote, so x equals k is a vertical asymptote of f of x if the limit as x goes to k minus as plus or minus infinity, or the limit as x goes to k plus of f of x is plus or minus infinity. Now, this is very important to remember. So we're going to ask some questions on this. Right now, it's not going to be that confusing because this is the only one you know. And so there's a lot of things where the statement I'm about to make right now is going to apply to as we proceed and do things more through this year. You guys are going to learn a lot of material. I'm speaking lots. And so it's very important to study things when I ask you to study. And even when I don't ask you to study, it's very important to study things, because after a while, and I say this every year, and some people choose not to believe me, and they find themselves in a very dangerous predicament. It's going to happen. It's going to be so much information sometime in the future that if you didn't study and get this stuff down, you're going to be ultimately confused. You're not going to know what to do and when to do it. So that happens. That happens every time people don't study sufficiently. So what I'm saying is it's very important to remember this information, because a little bit later, in fact, I think it's next lesson, we're going to do the limit. We're going to do limits at infinity and horizontal asymptotes. And it's very easy to confuse. This is not a limit at infinity. This is an infinite limit. So this is a limit that doesn't go to infinity. Well, that goes to plus or minus infinity. It's not a limit at infinity. A limit at infinity is a limit where x is going to plus or minus infinity. And horizontal asymptotes are based on limits as x goes to infinity. Vertical asymptotes are based on limits that equal plus or minus infinity. So it's very important to study so you get that distinction, because a lot of people get those two things confused. And so I'm stating a universal fact here. So this is very important to understand that if I'm claiming that x equals k is a vertical asymptote for some particular function, then the limit as x goes to k minus or k plus for that particular function has to be plus or minus infinity. No ifs, ands, or buts about it. No exceptions, no excuses. So if I'm declaring that x equals k is a vertical asymptote for a particular function, the limit as x goes to either k minus or k plus has to be, without question, plus or minus infinity. Now that's very important to understand and to remember. So it's very important to understand that and to remember that. Okay. Now, believe it or not, that concludes this lesson. So this was the key information here. And in an assignment, we may ask about this information in pretty clever and maybe even deceiving ways. But if you understand this information and knows this is the definition, this is the limit definition of a vertical asymptote. So this has to happen if I'm saying something is a vertical asymptote. Please remember that. These two limits, one of these two limits has to happen for me to say that x equals k is a vertical asymptote. If you remember that nice little fact, and please study that so to make sure it's something that you remember for the rest of the year, and hopefully, if you're lucky enough, for the rest of your life, make sure you study this, and this will be pretty important as we go forward. So we stop there, very short and sweet. And like we always say, we'll see you next time.